所以用 KCL、KVL 啊，然后 Ohm's Law， 还有串并联哈，那我们都可以解一些简单的电路哈，就是串联、并联再来，或者是 Y delta transformation 都可以解哈。那我们也试着我们解电路学是用代数的方式来解，反正你要解什么，我们都所有的 n 都当成 x1、x2、x3、x1000、100万、1000万没有关系哈。所以你这个电路很小的时候，我们刚刚讲的是前面是高中的是串并联，是很容易解。但是如果我一个 circuit 有1000个 component， 那根据我们前面代数的方法，就 2B method，then we have 2000 equations. Okay, so you have to solve 2000 equations. It's very cumbersome. Okay, and in fact, it's almost impossible to solve it by hand. So today we will introduce you in this chapter two professional methods. They are quite systematical. In other words, it's very easy to learn. However, okay, to be innovative, we have two more supplementary methods. 这个是买二送二，对不对？你们这个教的学会的，虽然课本只教2种方法，我们送额外2种方法。这个目的在哪里呢？你们这边有没有看那个是韩剧的？现在很多这个韩剧的韩女都侵犯到我们台湾过来了。你看那个七公主是不是？你看那个父亲，对不对？如果像那种时代的话，你可以看这个牛顿运动定律就不会出现了。说这个孩子说：“爸爸，苹果怎么从上面树上掉到地上来了？”对不对？如果是这种专制的父亲，马上啪啦一巴掌打下去，说：“苹果不掉到地上，难道往天上掉吗？”对不对？那就不会有牛顿这样的一个科学家了。所以我们这门课很重要，我们很希望是启发式的所以我们不光是课本上2种方法，我们额外新的2种方法让你看。如果你要写硕士论文、写博士论文，不是100年前嘛这个方法还没发明以前，你就说我的硕士论文提出另外一种创新的方法是 optimal， 就是 the number of equations to be solved is the minimum number 要解 unknown 的 equation 是最少数是最好的所以我们提供了额外2种的是期中考虽然不考，但是我们相信我们清华同学是全台湾是 top 1% or 2%， 所以是绝对可以看得懂，而且会有启发性。这个是你也可以更了解说，我们讲三民主义，我们这边有3个原理。Okay, so let's start the chapter. Okay, so remember for 2B method we use 3 principles: Kirchhoff current law and Kirchhoff voltage law, and also the component model. And so far we consider only Ohm's law. We have only one type of component, namely resistors, because in modern mathematics is rather simple, so that you can focus on the understanding of the new method. So see, this method is not voltage method. Instead of using the component voltage and component current, we use the node voltage instead of using branch voltage and branch current as a node. There are too many. Okay, here we can choose node voltage as a node. Okay, what is the definition of node voltage? Can you remember? A node voltage is defined as a voltage rise with respect to the reference voltage. 我们普通物理我们学过这个一个 potential energy 跟那个 kinetic energy。potential energy 它也是相对的所以我们说对有一个相对的坐标所以说 potential difference between 2 points。如果你 assign normally we use the ground 用地接地当的 reference voltage 的0伏特，所以我们可以说这一点电压是10伏特，是 with respect to the grounding voltage 是相对地来讲，physically there's no meaning to talk about the voltage at one point unless the other reference point is referred 所以你讲一点的电位是没有意那个电压是没有意思的，除非说相对哪一点的电压所以物理学叫电位差。Okay, so the node voltage is in fact with respect to the grounding voltage, which is denoted as 0 volt. Okay, and we know we have only n-1 node voltage. We have only n-1 node equations that are independent. Last time we talked about how to write the KCL equations for each node. For a circuit, there are n nodes. However, only n-1 nodes KCL equation are independent. The last equation can be obtained from the previous n-1 equations. And each branch voltage can be obtained from node voltage, and the corresponding branch current can be calculated by its component model. 它原理很简单我们不要用每一个 component 的电压当做 n node， 还有它电流当 n node， 我们用最少数目是 node voltage， 但是这样有没有意义 ？OK， 有没有意义？要看下面说，我最少数目的 n node 如果解出来以后，你想知道的任何 n node 都可以用我这边来找到答案，那它就有意义了。所以 this is very important concept. We can use a minimum number of unknowns, okay, to solve the problem instead of using 2B unknowns, okay. And once the node voltage are obtained, okay, then you can calculate the branch current and the branch voltage, okay, and also the power and energy or cost, okay. There's one advantage by using by choosing this as unknowns. Because for the previous 3 principles, you can see the Kirchhoff voltage law, okay, KVL, Kirchhoff voltage law is automatically satisfied. 我们3大部分呢，这样你选择 node voltage 当做 unknown， 就一下就省掉1/3了。So less work needs to be done, okay. So here, we need only find independent Kirchhoff current law equations, okay, and the component model is used to express the branch current in terms of node voltage. 因为解一个 equation ax 等于 b 这个 x 是 unknown 但是你在写 KCL equation 的时候，你写电流，并不是电压那怎么样呢？我们就用 Ohm's law， 因为知道电压，你就可以求电流所以各位可以看事实上我们只花1/3的这个功夫呢，可以把这个circuit equation 写出来，然后这个 minimum number So this is the basic principle of the node voltage. So we will consider some example to illustrate how to write down the network equations. But before doing that, I would like to classify into 2 cases. Okay, the first case we will consider the basic case, which in fact the resulting network equation can be obtained by inspection. 我们考试的时候不能说你这个答案是 by inspection， 这样就 by inspection。这个是就像我们练武功，我们上一讲就武侠小说一样，你是来练的高级的武功，你还从基本功从蹲马步开始，然后慢慢再变化，对不对？所以那个小说里面写缩时词那是快，一下出了多少剑，踢了多少腿，或是怎么样。那太复杂了，我们初学者一下我再教你这么一个天下第一剑的剑法呢，这个眼花缭乱，所以我们一招一招的拆解下来。The first case is again divided into 2 cases, sub-cases. The first one is the most fundamental one, okay? And the second one, there is a little variation, 稍微有一点变化，有点花招啊。所以武功到后面呢，你看起来会很美啊，这个是。但是开始这边是很枯燥的，像跟蹲马步一样啊，不过很简单，这样很容易懂。So this second variation is you can see we have dependent current source. Okay, for this case we get a resultant symmetrical A matrix, but here the resultant circuit matrix is no longer symmetrical. 啊，它的后面的这个矩阵呢，并不是对称的。And then we consider the second case. Remember, for node voltage method, we have to write the KCL equation, the summation IK equal to 0. However, in case 2, the circuit contains voltage source. For voltage source, we know only the voltage. Okay, we have no idea what are the currents. So in case you want to write the KCL equation, you have trouble. 你是写不下去的，因为 voltage source 只有电压，没有电流。So how to handle those cases? Again, here for easy understanding, we divide it into 3 sub-cases. The first one is the voltage source. A voltage source is 2-terminal component. Okay. For these 2 terminals, one terminal is the data node, the reference node. Okay. And for this case, we call this trivial case. The second case, the voltage source does not contain the data node. In this case, we can use a shortcut instead of using algebraic method. 如果代数的解法说，哎，老师你不用烦恼，我们在写电路就是代数的方法。我要写 KCL voltage source 没有电流，我就 assume IX， 对不对？那 unknown 电流不知道，我就是 X 嘛 ，IX 是 unknown。Okay, mathematically you are right. Okay, however, as a professional engineer, this is not the best way to do it. 这是专业的，你这样怎么样？如果我有100个 voltage source， 那你就多了怎么样？多了100个 unknown。The number of unknown, the number of equations, okay, is not optimal. 因为这一章我们要教的是 optimal 的一个专业的 professional method. So we call sugar node concept. By using this concept, the number of equation is reduced. 哎，你发现我不是增加 unknown 的数目不是增加解 equation 的数目，我们反而是减少 equation 的数目。所以这边有一个人生哲理这个是很要紧的。我举个例子，有些穷人说：“哎呀，糟糕，我口袋只剩下1毛钱或者说剩下1000块，明天日子怎么过？”他就整天就很痛苦的，这个面孔都扭曲的。乐观的人说：“哎呀，老天爷对我真好的，你看我 instead of empty， 这不是空空的，不是是零集合，口袋里还有1000块所以这边是一个人生的哲理，我们要从乐观来看 ，instead of 增加这个 number increase the number of equations. On the other hand, we can reduce the number of unknowns. 这个要学这无道一以贯之呢。各位同学，如果这样的话，你这堂课就是没有白上Okay, the third subcase is for dependent voltage source. 这个 dependent 我们说 this is virtual voltage source because it's a convenient model for modeling transistors. 这个有这一类呢也更复杂。Okay, so basically we have 5 subcases altogether. So let's see. Consider the first case. This is called basic case. We have, see here, 1, 2, 3, 4, 5, 6. So according to the 2B method, we have 12 unknowns. And then you use KCL, KVL, and component model. You can obtain exactly 12 independent equations. In other words, you can solve the problem. Okay, however, it is too cumbersome, okay? It's boring, okay? So we can do it more efficiently. So here we choose a node as data node. 我们首先选择一个 node 一个节点 当做一个参考单位。And here we use this symbol to denote grounding 这个节点这边画一个，有的是下面画一个箭头有不同画法那我们这画3横这样，表示接地这一点的 potential 电压是0伏特。So we have 1, 2, 3, 4 nodes, and we choose one of the 4 nodes as the datum node. Of course, you can choose this one or either this one or this one. Any one node is qualified as a datum node. Okay. So in fact, you choose datum node just according to the problem. Okay, what is to be solved? 你看题目要考你哪一个，你可以选一个最方便。This is the first step, and the remaining nodes we denote and node x1, x2, x3. See here we use e1, e2, e3 as a node. Okay, any question about the first step? So you can see the nodes are voltages. Instead of the branch voltage, we use the node voltage. If we use branch voltage, then we have 6 nodes. Here we have only 3 nodes. Okay. The second step, we can apply Kirchhoff current law to the remaining n-1 nodes. As we discussed before, we have only n-1 independent equations. Okay. So here we just write n-1 KCL equations for these nodes. Summation ik leaving this node equal to 0. Let's see, okay. For node 1 here, okay, we have I1 currents enter, so we put my sign here because we choose leaving the node as the reference direction of the branch current. So entering here, put my sign. And again, for this branch, the current I2 is my sign here. However, okay, the third one is the current source in this node. So we have 3 ampere here, again with mass sign. So summation ik limit equal to 0. So everybody knows about it. Then for the second node, okay, you can draw a circle around this node and you cut 3 branches. So it involves I2, I3, I4. And as you can see, I2 is leaving node 2. Similar for I3 and I4. So we have I2 plus I3 plus I4 equal to 0. Similarly for the certain node E3 here, okay, you can draw a circle and you cut 3 branches. So I4 is entering, so we put mass sign here. And I1 is leaving this node, so we have plus sign. And 4 ampere current source is leaving, so we have plus sign here. So we can write this equation, okay, to have some feeling about the systematic approach. We can put it in matrix form. We have a node I1, I2, I3, I4. Okay. Okay. We have to go to the third step here. To write KCL, we have to use the current. Okay. And next step, okay, we can express the branch current by using the component model. Okay, and here for resistors we use the Ohm's law. For current source, okay, their branch current are known, so there's no problem. So we can substitute the I1 current here. Okay, for node 1 here, you can see the current leaving node 1 is from node 1 E1 here to E3. So from Ohm's law, which is equal to E1 voltage minus E3 voltage divided by 3 ohm. Okay, this is mass I1. And similarly for mass I2, this current flow from node 1 to node 2. So you have E1 minus E2 and divided by 1 ohm. This, okay, we can consider the node 1 here. Yeah. E1 minus E2 divided by 1 ohm. That's the current through this resistor. And here is 3 ampere is known. However, with mass sign here. Okay. So now you can see we have expressed the branch current in terms of the node voltage. Okay. Similarly, for node 2 here, we can find the current in these resistors and in the other 2 resistors. So you can see the branch voltage can be expressed in terms of node voltage by simple subtraction. Okay. 简单的减法，这一点减电压减这一点电压除以它就是它的电流。所以我刚刚讲的是说，如果你的 node voltage 不能够帮你找出你要求解的答案，那你选这个 node voltage 是没有意义的。现在都可以的，我们 so far so good. Okay. Similar for third node, okay, right? So to have some feeling about the systematic way, we put it in the matrix form. Okay. So for E1 here, okay, matrix multiplication, so everybody knows about that, right? 矩阵乘法都学过了嘛，这个 row 乘着 column 的这一个， so you can see E1 here we collect the same terms about E1, 1 over 3, 1 over 1, okay, 1 over 1, 1 over 3. So similarly for E2, okay, we have mass 1 here, and E3 here with 1/3 with mass sign. Okay, similarly we can collect the similar terms E1, E2, E3, get this row and this column equal to 0. Okay, so let's see for this basic case. In fact, you don't need to go through step 1, okay, step 2, step 3, okay. You can just write down the answer directly. How? Okay, how to do that? Okay, see, the matrix can be obtained by inspection. You can see here is a square matrix. First, we will consider the diagonal terms. Okay, for the diagonal terms, in fact, they are the sum of the conductors connected to that node. Okay, for the off-diagonal terms, they are with mass sign. Okay, with the, in fact, the negative of the sum of conductors directly connecting nodes K and J. Okay, with K not equal to J. Okay, and the right-hand side here is in fact the sum of the independent current sources entering to the node. Okay, so let's see. So in fact, in case I give you a problem or a circuit like this, and you can see, we have only independent current source. Okay, and we want to use node voltage method to solve this problem. And this belongs to the basic case. We can write the circuit equation directly. First, consider diagonal terms 1, 1. Okay, with node 1. How many components connect to this node? 1, 2, 3. But only 2 resistors connect to this. So we have sum of the conductance. This is resistance. So conductance is the reciprocal of the resistance. 这3个导数的相值，然后这个155导数就是1。And how about the second diagonal terms, E2 here? We have 3 resistors, okay, connect to this node. So we have 3 terms, and their corresponding conductance 1 over 1, 1 over 2, 1 over 3. Okay, quite simple, right down. And the third node here, we have only 2 resistors connect to this node. And again, the sum of the conductors is 1 over 3 plus 1 over 4. Okay, so we can obtain the diagonal terms. And then we consider 1, 2, first row, second column. Node 1 and node 2, they are only one component connected to these 2 nodes, 1 ohm. And with mass sign here, of course. And the conductance is 1 over 1. Similar for 1, 3, node 1 and node 3. Okay, only one resistor connect between node 1 and node 3, is 3 ohm. So we have 1/3 is mole or Siemens, and again with mass sign here. And similar for 2, 3, okay, 这1、2、1、3然后2、3 okay. Between node 2 and node 3 we have 4 ohm resistors, and with mass sign, and conductors 1/4 Siemens. And this is symmetric, 所以2、1的 component 跟1、2这个 diagonal 这个 off diagonal component 是对称然后这个1/4、1/3是对称的，1/4、1/3是对称的。Okay, this is the left hand side, okay, the A matrix. Now how about the right hand side? 我们前面写 summation of current leaving this node equal to 0. However, for those current source, they are knowing, okay, 那电流源，它的电流本来就知道了， so we can move to the right hand side 的 equation. 这等号我把它移到右边，等号的左边的是 summation of current leaving this node. When you move to the right hand side, the first meaning is the current entering to the node. 知道吧？所以我们在讲 KCL 是有第三个 version, summation IK leaving 等于 summation IK entering. 事实上就是为这边来讲，知道吗？所以右边是 for all the currents entering to that node. So let's see. Consider node 1 here. We have only one current source, 3 ampere, entering, so we have plus sign here. And node 2 here, we have no current source entering, so put 0 here. And the third node here, we have 4 ampere leaving. Instead of entering, so put minus 4 ampere. So is that clear? So we are asking some student, okay, volunteer not come by here and work out. We want to learn the node voltage method. 我说电路学非常简单，很轻松愉快你们一定相信，不相信我现在就 proof 这证明给你看。Would you please pull up the screen?